Good evening, ladies and gentlemen. It's a pleasure to speak at this international reception on the Centenary of the Medical Research Council and to present some of the international research studies that we undertake as part of our research at the MRC Life Course Epidemiology Unit at the Universities of Southampton and Oxford. The scientific mission of the unit is to delineate the environmental causes throughout the life course of chronic musculoskeletal disorders, osteoporosis, sarcopenia and osteoarthritis, and of obesity and its sequelae, type 2 diabetes mellitus and cardiovascular disease, and through an understanding of these environmental determinants to develop population-based and high-risk preventive strategies against this group of important disorders. Our three programmatic themes are of musculoskeletal aging, of nutrition development and lifelong health, and of work and health. And today I'll outline for you first the international dimension to the epidemiology, prevention and treatment of osteoporosis throughout the life course, my subject of research over 30 years, with a focus on the patterns of disease occurrence and risk assessment and treatment, before turning to the developmental origins of health and disease and focusing on both maternal vitamin D status as a determinant of childhood body composition, as well as contrasting preventive strategies in transitioning and in non-transitioning populations, studies that we've undertaken with Professor Caroline Fall in the United Kingdom and India. So first, osteoporosis. We've recognized fragility fractures since antiquity. At the bottom left of this slide is a section of spine removed from a Saxon barrow just outside of Wells in the 8th century AD, and it clearly shows a vertebral compression fracture. In the 1850s, orthopedic surgeons commented on the fact that bone removed from elderly skeletons revealed increased porosity and coined the term osteoporosis for this disorder. But it's really over the last 2 decades that we've moved from believing this to be an inevitable consequence of aging to being able to assess risk and to develop preventive strategies. And the first international venture in this dimension was undertaken by the World Health Organization with input from the unit in 1994, when, in addition to the descriptive definition of osteoporosis, a disorder characterized by low bone mass and microarchitectural deterioration of bone tissue, leading to an increased risk of fracture, we were also able to delineate a dual energy X-ray absorptiometric threshold for osteoporosis, 2.5 standard deviations below the young normal mean. And you can see this distinguished WHO working group, which reformed in the last 5 years to establish the principal risk assessment methodology for fracture, known as FRAX. Thereafter, the age and sex-specific incidence rates of fracture were discovered through collaborative work between epidemiological groups in the United States, most notably at the Mayo Clinic in Rochester, Minnesota, with our own group. And these characterize the incidence patterns that you see here for vertebral, distal forearm, and hip fracture. And for all three fracture types, and for both men and women, you see a progressive increase in incidence with advancing age, such that radiographic vertebral fracture has the highest incidence in women at all of the ages above 65. Around 1 in 3 radiographic vertebral fractures comes to clinical attention as clinical vertebral fracture, and these are contrasted here with wrist and hip fracture. Globally, those collaborative ventures have been extended through the International Osteoporosis Foundation, which has been involved through collaborative EU frameworks 5 to 7 in the mapping of geographic variation in fracture incidence, the development of therapeutic modalities, and the assessment of risk. The IOF publishes two of the major osteoporosis-related journals, Osteoporosis International and Calcified Tissue International. It organises a biannual World Congress in Osteoporosis, the next of which is in Seville in 2014, and it organises an annual training course on osteoporosis that is the envy of investigators worldwide. The epidemiological studies looking at geographic variation in hip fracture incidence pioneered by the IOF have resulted in the map that's shown here, with the highest rates observed in Northern Europe and parts of Southern Latin America, intermediary rates in North America and Russia as well as the remainder of Europe, and lower rates in populations that have not undergone the nutritional and economic transition, for example, China, India, and Northern Latin America. These differences in hip fracture incidence are substantial, and the causes for them remain much of the subject for our research. As I intimated, that WHO working group reassembled in 2008 to develop the WHO Fracture Risk Assessment Tool, or FRAX. This utilises 12 items of information on men and women presenting for clinical attention with osteoporosis as a concern. In addition to age, gender, height and weight, they're asked about previous fracture, about a parental fracture history, about current smoking, rheumatoid arthritis, glucocorticoid use, and use of alcohol. On the basis of these, coupled with a bone density measurement, a 10-year probability of either hip fracture or of a major osteoporotic fracture is derived, and this is shown in the red panel at the bottom right. And on the basis of that 10-year risk, placed against age, we can develop algorithms for the most effective use of pharmacological treatments, so that you can see on the right-hand panel the intervention threshold for bisphosphonate use in the currently developed UK and European guidelines for osteoporosis management. I now move to the other end of the life course, the fetal and infant stages. And this provides me the opportunity of paying testimony to my mentor and predecessor as director of the MRC Epidemiology Unit, Professor David Barker, who sadly passed away last year. David, during the 1980s, noticed that the map of coronary artery disease today resembled that of infant mortality some 7 decades earlier. From those ecological observations, he went on to show a relationship in individuals between low birth weight and an excess individual risk of cardiovascular disease and many of its antecedents. And he went on to develop the developmental origins hypothesis, the notion that environmental perturbations during critical periods of development, most notably during intrauterine life, lead to changes which alter long-term structure and function of the organism and establish the risk of later non-communicable disease. And this developmental origins hypothesis, which had to be argued for strongly during the 1990s, has now underpinned life course approaches to the prevention of non-communicable disease. And the overarching scientific framework for our current research programs is that a young woman's diet, body composition, physical activity, education and lifestyle before and during pregnancy modulates epigenetic changes, methylation in the promoter region of key genes, during the period of life when development is plastic. Infancy and childhood environment then modulate the expression of genes established during this phase of developmental plasticity and set up the vulnerability to chronic disease in later life. And this is, of course, modified by later environmental risk factors. This extended to prevention suggests that for non-communicable disease in the population, we can, of course, conceive of adult interventions which will be of relatively high impact in vulnerable groups, but have a relatively small impact across the population as a whole, and extend these to interventions early in the life course in the infant and even in the mother. And these may actually establish the risk trajectory on a lower level and have much more profound alterations in terms of improved population health. It is this area of etiology and intervention that I shall now illustrate with regard to osteoporotic fracture. So our research over the last 15 years has established that low birth weight and poor growth in infancy are associated with reduced bone mass, reduced bone geometry, altered bone microarchitecture, and reduced bone strength, which in turn lead to an increased risk of hip fracture. And in this cohort study in Helsinki, coupled with the data from Hertfordshire, we see that across the range of childhood growth expressed as a change in adiposity, there is from high to low adiposity a progressive increase in the risk of hip fracture many decades later. Among the modifiable determinants of bone mass that we've identified during development, maternal vitamin D status is the most easily manipulable. And we published in The Lancet some 8 years ago the association in a mother-offspring cohort study in Southampton between maternal 25-hydroxyvitamin D and bone mass in the whole body, bone mineral content, bone area, and areal bone density. These studies have now been extended to develop mechanisms which might underlie them, as well as to characterize bone growth in utero with high-resolution ultrasound. The epigenetic mechanisms relate to vitamin D signaling. So, for example, in exploring methylation across the genome and identifying candidate genes within which early environment alters methylation, and that altered methylation results in an alteration in neonatal and childhood bone mass and volumetric bone density, we've recently published in collaborative work with Singapore and Auckland through our consortium known as EpiGen that methylation at the RXRA locus, retinoid receptor A locus, modulates bone mass and volumetric bone density. And this pathway, RXRA, is very closely linked to the signaling pathway for vitamin D activation. RXRA and the vitamin D receptor are heterodimers which, when they're activated by 1,25-dihydroxyvitamin D, turn on the 1-hydroxylase gene. And just next door to this heterodimeric signaling lies another molecule, MBD4, which mediates parathyroid hormone signaling and undergoes methylation as an on-off switch regularly throughout life, and is a much more fine-tuning mechanism for 1-hydroxylase expression. Finally, this has led to an intervention study in the general population. So we have taken a series of 915 pregnancies, attending at 12 weeks, and randomized them to receiving a vitamin D supplement of around 1,000 units daily, or placebo, with the primary outcome measure the bone mass of the offspring at birth, and subsequent follow-up extended to 4 years. Lastly, what about populations in different parts of the economic, social and nutrition transition? For this, the best example of our research is that undertaken under the leadership of Professor Caroline Fall at the unit on intergenerational programming of health and disease in India. Caroline has established a series of adult and mother-offspring cohort studies in New Delhi, in Pune and in Mysore, all of which have led to associations linking growth in utero and infancy with adult adiposity and its sequelae. Perhaps most interesting of the studies in India is a trial undertaken in Mumbai, where a preconceptional nutritional supplement rich in micronutrients was randomly allocated to a group of 6,500 women before pregnancy. 1,565 of them became pregnant, and you can see in the right-hand panel the influence of the intervention on birth weight and the interaction between that intervention and the mother's pre-pregnant BMI, with a significant gain in birth weight for those whose mother's pre-pregnant BMI was in the highest third of the distribution. And this trial, which has just been completed, has an effect size on birth weight and on gestational diabetes mellitus of 7% versus 13% in the intervened and control groups respectively, and the children will be followed up to look at long-term growth, body composition, cardiovascular risk markers and cognitive function at age 6 years. So I hope that I've shown you that our research with a marked international dimension has led to a complete revision of the way in which we approach the prevention of non-communicable disease. The Global Action Plan of the World Health Organization for the prevention and control of these disorders for 2012 to 2020 now takes on board this life course approach, something that would have been unheard of 2 decades ago. It addresses the maternal health of the unborn baby and points to the importance of maternal and child health programs alongside care of the elderly and in a range of settings to try and reduce the burden of chronic musculoskeletal and metabolic disease. For the future, we want to knit together the observations we have made in bone with those that are apparently available now for muscle, in terms of the causation of sarcopenia, and for the commonest joint disorder in Western populations, osteoarthritis. And through sarcopenia, we will see a link to body composition as a whole, the balance between bone mass, lean mass, and fat mass. The understanding of the developmental mechanisms in this area, the development of biomarkers, the execution of appropriately positioned intervention studies and of targeted preventive strategies will comprise our future strategy. I'd just like to close by thanking all of our collaborators worldwide, all of the members of the MRC Life Course Epidemiology Unit, both at the Universities of Southampton and at the Universities of Oxford, all of our funders, and of course, most importantly, the Medical Research Council. Thank you very much.